Welcome back. I'm cranking videos on the weekend, basically just continuing with the math series and the function series and really getting in the calculus in a fun way. What I did down here was kind of fun is I just have an equation that obviously parabola from arguments, but I've sectioned off a section of that through evaluating the function from not only from one end to the other, which I piped here. I kind of continued the scripts I was doing earlier, but I wanted to show like these little nests, like what to pull out. Like pulling your surface is a nice little algorithm. Pulling your endpoint tangents is another thing you can do as well. You get at least endpoint tangents, one coming into the curve, one leaving the curve, and you could of course reverse that, similar to Grasshopper 1. And then I've got this little divide quotient, just dividing the circle so I can move along it, but also analyze the derivative of the curve as we go, which is kind of nice. And then you can actually find more derivatives as you want, which is pretty awesome. You can see it's just being calculated until it kind of becomes obsolete. That's kind of nice. And then you can also analyze back from your initial curves where you wanted to frame it. So if I drop that below, actually, if I drop this one below, you see the derivative changing. Just you grab a lot of control. You can see how the derivative has to change and then move into the negative. And then what I did up here with the pink line was something totally different. I think that's all I did up. I'm just putting my extra little scripts. Oh, the other thing was a pipe, and I thought I wanted to use this preset picker, which is really nice. You can flip through anything that has a preset, like a mesh pipe, and you can click through here and go from box to flat. You don't have to enumerate through it with the number slider. So that's a really nice tool called a preset picker. So I just wanted to involve doing that. And actually, I think I like the box, or let's do dome, which is kind of nice, caps the ends. All right, so what I've done here on top of that is I just keep extending the scripts. Is I thought I'd play with the general difference quotient, which is either way you want to write it, function b minus function a from BA, or you can just reduce that to h. So what I have going in here is from a point on x at a, which will come up at f at a. So a and f at a shows up here on the function curve, and then b at and then basically just to understand that quotient, just write it through the old school way of whatever h, or the difference between b and a, is getting to 0, which is really what calculus solves, you end up solving accurately what the slope of that function is. Of course, this kind of shows as you move back to that initial number as the slope gets more and more appropriate for the curve, it just disappears to not a number. I think it does, or the line itself just ends up giving up no information. So you can kind of play off of both sides of where you want that slope to be. And so think about what calculus is really calculating. It's just trying to get the h, or the difference between b and a, down to 0, and then you're really calculating the slope of that curve right at that point. Now there's other functions in here that do that, which are worth playing with. And obviously that's tangent on curve, and that's basically what's happening. But for people starting out in calculus, that's kind of a nice little formula. So that's it. Just putting it on, making models, keep going, try and get as many scripts going as possible. What I would recommend, which is something that I'm actually going to do, is jumping in here and not only jump into all these tools and curves and surfaces and glossary, maybe start, the topics seem a little general. I don't know if I'm really interested in color models, continuity, topographical faults, but really get into the specifications. It starts with curve, jump into analysis, and start taking a look at what each one, read through each one of these. And I think it'll stick in your mind kind of like any developer notes in Rhino Common or like in Unity, that you end up knowing that these things are here. And what you'll solve are little things that are pretty sneaky, but pretty nice. Like down here, when I have to evaluate a function, I think I slid it up into here. Sorry, I'm jumping around, but things are still kind of new. Control point here. Yeah, this is nice because you're playing with the loci, or the locus of a point, and it's really a percentage, which is really nice. So as I take that curve from 0, the beginning of where I wanted that curve, traditionally you'd have to reparameterize curves. What's nice is this loci allows us not to have to bother with that. We could just go from 0 to 100% of the curve. Really nice way of actually thinking about like where we want to go. And then I had a number of derivatives. That's another tool that you just start to read about, and you have to make the shift of what it was as Grasshopper 1 into what it is as Grasshopper 2. So that's basically it. And there's your script as it grows. We'll save it, we'll add more, and we'll jump a little farther into it. Thanks for watching. I'm just going to save that and turn it off at 5 minutes.